Another thing I want to highlight before we can finally move on to building the actual character is the following. Make sure that your textures are bright. It's better to have brighter textures and then two bright textures and then darken them in Unreal than to have two dark textures and then brighten them in Unreal. I made two different reflection textures here. These are two noisy textures, kind of cloudy, murky textures that we're going to use later on to fake reflection with. One of them, the two, is rather bright. The other one is dark. Now this doesn't just go for reflection, this goes for anything. Let's say that you have a character and he has a very dark coat or he has a very dark armor. It would be much wiser to make that armor much brighter in Photoshop and then darken that armor, darken it in Unreal, than immediately making the texture dark in Photoshop. Likewise for this, I can clearly show you with the reflection texture what would happen. Even if you don't want very intense reflection, it's better to go with a bright texture than immediately making the texture, the reflection texture, not very intense, like this. Because if I were to use this in a material, it's much easier to make the bright one darker by just multiplying it, and it will still look nice. It still looks nice and smooth. Than it is to make the dark one brighter. So if I now say, okay, this should actually be brighter, then you will very quickly get this. And this is intensely ugly. As you can see, it's very heavily compressed. And you would never get this with the bright one. Because what basically happens is if you were to look at a texture in Photoshop, this bright one uses all the brightness levels available. You have 255 colors to go with. You have 255 levels of bright. All the way there, from there to here. This pixel, for example, is this bright. This pixel is here. This one is there, etc. So this image makes use of most of the pixels available, most of the brightness levels available. So you have 255 shades of gray, if you want to call it like that, available to work with. However, the dark one, see, every pixel I click never goes above this line. It only makes use of 30% of the available shades of gray, or colors in general. And that's unnecessarily limited. It's much better, you will get much richer results if you make use of all the shades available, of all the different types of colors available, and then scale that in Unreal, rather than limiting yourself to only use a couple of pixels here. And that's why you're getting the banding in Unreal, that's why you're getting this. Because there's only a limited number of shades of gray that it can use. And therefore, once you start to brighten that up, you start seeing the clear difference between, okay, this was one shade of gray, or one color, this is the next, this is the next. And you lose the subtleness that you would have had if you would have made it brighter. See? This is much better quality. You still get it a bit because it's still compressed after all. But even if I go rather bright, well, it's not perfect. It's in any case a lot better than this. So again, if you need dark textures, make them bright in Photoshop and scale them in Unreal. Don't make them dark immediately in Photoshop. You will get worse results in the end. Also, one other thing completely unrelated, but to close off the whole technical section here, the first part of the video, at the bottom of every material there is a section called Usage. There. And this has flags set. These flags should be set correctly, depending on what the material is used for. So this is now used with static lighting. So most environment materials have this enabled because they're used with static lighting in the environment. However, since we're going to be making a character material in a bit, we should enable use with skeletal meshes, because that will enable it to be used on skeletal meshes. So you should turn on the box so it corresponds with how it's used in the game. If you don't do this, it will still work just fine in the editor, but in the game, in the standalone game, it's probably not going to show up. And even if it does show up, once you cook the game and make an installer out of it and all that, at that point it's very likely to fail if this is not correct. So you need to be accurate with this and enable it if it's used with a certain feature. or otherwise you will eventually run into problems. You should keep an overview on how much you use in a level. There's a couple of ways of doing that. First of all, you can simply play the game. And then you can type following texture groups. You simply type texture groups. And in the log file, and always make sure you run the game with log file. I always run the editor and the game with the log file. You do this by adding a shortcut or a command line to the shortcut of the game. So add this at the end of it. For example, like that. Then you will get this window and it will give you a bit more control over what's happening. Now when you type texture groups in the game, it will output this list. Again, these are the same lot groups as seen earlier. And here it shows me there is 576 world textures currently used in this level. That currently amounts to 17 megabytes, about 18 megabytes about, in memory in use. And the total size, if everything would have been fully loaded, would have been 54 megabytes. So you can see per section how much it's using. There's 312 light maps, amounting to 30 megabytes in memory. So 30 megabytes of the memory is spent on light maps. And if it were to load all light maps in a level at once, that would be 55 megabytes of light map information. So this gives a nice overview already. Best to do this actually in-game, not in the editor game, but in the standalone game, because the editor will add some more stuff to the memory that shouldn't really be there. I mean, the editor doesn't really give a fully representative picture of what's really going on, but it's a start. So again, you can get that by typing texture groups as a console command. Also, very, very useful is view browser windows, primitive stats and texture stats. I'm gonna open both of those. That gives you these two windows. When you open them, they're empty, but if you press F5 to refresh them, it refreshes the list. You can do that on both. Primitive stats gives you an overview on the 3D, all the 3D data in the scene. So here you can, for example, sort it. There's 129,000 triangles, but if we count the instance ones, there's 1.9 million instant triangles in view. Or not in view, sorry, in the level in general. And you can basically sort it. So the highest, the model with the most polygons, this is the model _0. This is actually the brushes. So the brushes amount to 8,184 triangles. Then this mesh is 6,974 triangles big, and it's used 9 times, amounting to 62,000 triangles in total in the level. If you double click that, it will select it. So now I can see this mesh is rather high poly. So if ever you get to a situation where the game is too heavy, it's too much, you can see which one has the biggest impact. This one is used 382 times. There's 382 draw calls. And that's this one. So if you're going to try to reduce draw calls, I would say that this is a prime candidate to begin with. Etc. If a bit further into the list, it also says resource kilobyte. So you can see that all the 3D data combined in level is only 10 megabytes of, it only takes 10 megabytes to remember all the meshes. Again, the brushes amount to 1.9 megabytes, so the brushes are by far the heaviest. 500 kilobyte is spent on this, I think that's a city somewhere. That takes 500 kilobytes. So you could actually say in this case, the biggest mesh in memory is a mesh far away that you can barely see. Perhaps it's not worth having this one in. Perhaps we should do this. Etc. There's a couple of other things you can see. You can also see how much light mapping there are here. There's 17 megabytes of light maps for these meshes. You can see the vertex colors as well. There's no vertex colors in here, I think, in this level. But if you were to have assigned vertex colors, you would be able to see how much those take on the meshes, etc. Texture stats works in the same way. So here we have the texture stats. We can see where the biggest and the smallest textures are, what their current size is, because again they might be lot biased, so they might be smaller than they really are, than they were originally. You can see what type they are. That's actually something I should also mention. I'll do that in a little bit. You can see their current lot bias. You can see what group they belong to. And most importantly, you can see the memory they take. This is what the whole level takes, and this is per asset. Again, current kilobyte and the first number there, that's what it currently takes. This is what it can maximum take if it were to be fully loaded, if it were to be rendered in full resolution. You can also see that the skybox here is incredibly inefficient. It's set to uncompressed pretty much. This means it's uncompressed. And the sky takes 10 megabytes, 11 megabytes almost. Also, the second part of the sky takes another 5 megabytes. And then there's a couple of mobile flattened textures used, 1.3 megabytes each. So you can use this to analyze and to find things that are very inefficient. I would have never accepted this. I think this is way too inefficient for what it's worth. I understand why it was done, because the sky has a lot of subtle gradients, and if you were to try to compress that, it would be very obvious and would be ugly. But spending 10 megabytes on it, I think is a bit too much. So right, the format here, you can also see that format if you look in the content browser. So in the content browser, if you hover over something, it says on the second line info, it says DXC1. So DirectX texture 1. Everything that has no alpha is always DXT1. At least in Unreal, not necessarily in other games, but in Unreal, everything without alpha is DX1. And everything with alpha becomes DXT5. You can see this one has alpha, it's DXT5. So you can now easily look in this list, and you can see all of these textures have an alpha channel. All of this. And I don't think you really need that many alphas. A lot of these could have probably been brought into a merge map, because this is a lot of alpha right here. Everything that's DXT1 has no alpha. And then there's a couple of other types, like this is grayscales, and this is uncompressed. Also regarding grayscale, first of all, uncompressed, very bad idea, because it adds a huge, it makes it a lot bigger. So unless you really need it, perhaps for a sky indeed, but unless you really need it, you should not use uncompressed. And grayscale doesn't really do what you think it does. If you were to say, for example, I have my cloud here, or the smoke cloud. Okay, well, the smoke doesn't have any color. It's this texture right here. We could go for grayscale compression. Very bad idea as well. Name it as a different file so it gets obvious what's going on. Smoke 2. Probably will get better quality because it's basically uncompressed, and that's also exactly the problem. So the original smoke texture is 342 kilobytes. This one is set to grayscale is 1.33 megabytes. So grayscale can have a huge impact, and it's only a 512 by 512 texture. So if you have to do grayscale on a 2048, you're basically making a 10-11 megabyte big texture. Not the best idea. So I never ever set anything to grayscale. It sounds like it's more optimized, but in reality you're importing an uncompressed texture, which isn't actually grayscale at all.